If we are going to talk about gases on a molecular level, then we really need to cover a bit of chemistry. In particular, we need to understand how chemists deal with particles in a gas, and that is through a quantity known as the mole. The mole is a base unit, and it is the amount of substance. Basically, we could just say we have 1 apple, 10 pencils, 1,000 hairs, 1,000,000 likes. But what about when the numbers get really, really big? Just like we use things like atomic mass unit and the electron volt when we are dealing with really small particles, we use the mole when we are dealing with huge numbers of particles. Its definition is 1 mole is 6.02214076 times 10 to the 23 particles. Now, that's not a very convenient number, but obviously it has a good reason to be like that, and it's very similar to the atomic mass unit. Chemists like working with carbon since it can be controlled well, and it just so happens that 12 grams of carbon-12 has 6.02214076 times 10 to the 23 particles in it. Anyway, the important part is that we say that 1 mole of carbon is 6.02 times 10 to the 23 particles of carbon. 1 mole of iron is 6.02 times 10 to the 23 particles of iron. 1 mole of water is 6.02 times 10 to the 23 particles of H2O. That's 6.02 times 10 to the 23 particles as in molecules. So the number of individual nuclei, for example, could be 3 times that. Okay. Obviously, the number 6.02214076 times 10 to the 23 has a name, and it is Avogadro's constant, with symbol N subscript capital A. The total number of particles in the substance N is given by capital N equals Na multiplied by the number of moles. So big N equals Na times small n. We're going to come back to this in future lessons, so keep a note of that. Back to basics though, why do we need this? Well, let's imagine we have just 1 meter cubed of nitrogen. Looking at a periodic table, I can see that 1 nitrogen atom has 7 protons and 7 neutrons. So its relative atomic mass is 14. If we look back at the definition of the mole, it was based on carbon. Carbon, with its relative atomic mass of 12, has 6.02 times 10 to the 23 particles in 12 grams of the material. Relative atomic mass 12 grams, 1 mole. 1 mole of carbon-12 has a mass of 12 grams. Linking this up, we can also say that 1 mole of nitrogen-14 has a mass of 14 grams. In our problem, we know we have 1 meter cubed of nitrogen, and we know its density is 1.25 kilograms per meter cubed. I just looked that up. So the mass is 1.25 kilograms. 1 mole is 14 grams, or rather 1 mole is 14 times 10 to the minus 3 kilograms. So 1 over 14 times 10 to the minus 3 moles is 1 kilogram. 1 over 14 times 10 to the minus 3 times 1.25 moles is 1.25 kilograms. We have 89 moles of nitrogen. Okay, that's 89 times Avogadro's number of particles, by the way. 5.4 times 10 to the 25 particles. 89 moles is much easier.